In early May, the U.S. Air Force officially kicked off ground testing for the Collaborative Combat Aircraft program. At the same time, defense tech company Anduril released the first-ever footage of its YFQ-44A drone undergoing trials at a test site in Costa Mesa, California. This marks a major milestone for the CCA initiative. With YFQ-44A entering ground testing, the program is now transitioning from concept to reality. And that also means its sibling aircraft, the YFQ-42A by General Atomics, won't be far behind. In the coming months, the U.S. military will rigorously test both drones, focusing on propulsion, avionics, autonomous capabilities, and ground control interfaces. The goal is to minimize risk ahead of their first flight. According to the Air Force, between 100 and 150 Increment 1 CCA are set to be deployed by September 2029. Each F-35 or future F-47 manned fighter will be paired with 2 CCA, dramatically expanding situational awareness and battlefield reach. The pairing is expected to enhance battlefield sensor fusion by up to 300%. Once operational alongside the F-47, a single CC-enabled unit will be capable of covering an operational radius of up to 1,500 kilometers. The first CC-ready base has already been selected, Beale Air Force Base in California. That all sounds impressive, but when the YFQ-44A was first unveiled, reactions to its appearance were lukewarm. With its single turbofan engine, belly intake, and vertical tail, many observers noted it looked like a scaled-down, pilotless F-16. The conventional layout and small frame, just over 6 meters in length, with no internal weapons bay, seemed underwhelming, especially for a drone expected to operate alongside 6th-generation fighters. But don't let looks deceive you. The YFQ-44A, previously known as the Fury drone, is built by Anduril and is designed around modularity and flexibility. It features a 3-wheel landing gear system and standard runway takeoff and landing. Powered by an F-44M turbofan producing 1.81 tons of thrust, the drone can reach near supersonic speeds, up to Mach 0.95, and pull 9G in high-speed maneuvers, outperforming most current-generation man fighters in agility. Its modular payload bay can carry up to 180 kilograms of gear. Radar systems up to 300 millimeters in diameter can be mounted in the nose, with additional side-looking radars on the fuselage. But to keep costs down, the YFQ-44 doesn't have an internal weapons bay. Instead, it uses underwing pylons to carry weapons like AAM-120 AMRAAM. This reduces production complexity and cost, but at the expense of stealth. And with its compact frame, even 2 external missiles appear bulky, impacting its aerodynamic efficiency. Still, there are stealth elements built in. The air intake has been redesigned for a more forward-swept appearance, and the nose landing gear features a trapezoidal door for better radar deflection. On top of the fuselage, a conformal antenna array and auxiliary air intake are visible. Other test-specific gear includes forward-facing cameras and flight data probes, which will be replaced by an infrared search and track sensor in operational versions. Anduril has already showcased a low-cost IRSD solution in development. On the other side of the CCA program is the YFQ-42A, developed by General Atomics. It's a completely different design philosophy, derived from the earlier XQ-67A drone. This aircraft has a 5.8-meter wingspan and a takeoff weight of about 1.2 tons. It uses a straight mid-wing layout with a V-tail and a prominent dorsal air intake behind the cockpit area. Just like the YFQ-44A, the YFQ-42A supports a variety of electronic systems, such as compact airborne radars. But it goes a step further by adopting a universal chassis framework, allowing different mission modules to be installed for tasks like reconnaissance, electronic warfare, or ground strikes. Crucially, the YFQ-42A does include a small internal weapons bay for added stealth. So what are the operational roles of these 2 very different drones? The YFQ-42A is clearly optimized for stealthy penetration missions. Its low profile and internal weapons capacity make it ideal for high-risk tasks like deep strikes or electronic suppression. Its modular radar bay allows it to support distributed sensor networks across the battlefield. The YFQ-44A, on the other hand, is built for speed and agility. It's likely to act as a frontline shield for manned fighters, performing high-speed intercepts or serving as a decoy to trigger enemy air defenses. When paired together, these two drones form a complementary strike force, stealth infiltration from one and high-speed distraction or offense from the other. Of course, neither drone is perfect. They're both part of Increment 1 of the CCA program, and naturally there are compromises. The YFQ-44A, for example, sacrifices stealth to achieve its speed and maneuverability. And while the YFQ-42A includes stealth features, it's smaller and may carry lighter payloads. Still, their development is progressing quickly. From initial concept to prototype designations, YFQ-42A and YFQ-44A took just 2 years. This is the first time the U.S. military has officially used the fighter drone designation. In actual combat roles, the YFQ-42A is expected to perform precision strike and suppression missions, while the YFQ-44A will likely focus on gaining air superiority. And this is just the beginning. Both aircraft are part of Increment 1. For Increment 2, major defense contractors like Boeing, Lockheed Martin, Northrop Grumman, and Raytheon are expected to join the competition. And with advancements in artificial intelligence, future CCA drones could become even more autonomous, making real-time decisions without constant human input. It's worth noting that the CCA project is really a combination of multiple subprograms. The foundation for today's CCA drones goes back to the 2015 Loyal Wingman concept. Over the decade, programs like the Skyborg AI project and YFQ-58 Valkyrie demonstrators laid the groundwork for what we're seeing today. These were integrated into CCA starting in 2024, with full-scale development accelerating in 2025. On March 3, 2025, during the Air and Space Forces Association Warfare Symposium, the Air Force formally revealed the YFQ-42A and YFQ-44A as the two selected Increment 1 prototypes. But there are still challenges ahead. Neither drone is truly stealthy in the way manned 5th or 6th gen aircraft are, and cost is a growing concern. Each CCA drone is expected to cost around $20 million, about 1/4 the price of an F-35. That's affordable compared to manned fighters, but expensive for drones. They're expendable in theory, but losing one still hurts. The future scope of the program is also unclear. While the Air Force plans to initially use CCA for air-to-air missions, later versions may be adapted for strike and electronic warfare roles. But competing programs like new air superiority fighters and survivable aerial refueling tankers are still competing for budget and attention. Still, if the CCA program scales up to 1,000 units, operating in coordinated swarms, they could revolutionize aerial combat. Warning times for enemy air defenses would drop to mere minutes. The survivability of manned aircraft would plummet. Manned-unmanned teaming could become the new normal in modern warfare. So what do you think the future of Increment 2 will look like? More stealth? Better AI? Leave your thoughts in the comments below. We'd love to hear what you think. Thanks for watching. Don't forget to like and subscribe if you enjoyed the video. See you in the next one.